Hey guys, it's your boy, here back again with another physics problem from the exam, or the test rather. It's not quite a full exam. Here we have a problem that is marked ENH, which means that this is relevant for the easy, normal, and hard versions of the exam. There's going to be a problem that's kind of like this on all three of them. So in this problem we have Miss Amo dropping a backpack full of cement off the school roof, 15 meters above the ground. How long does she have before it strikes the blacktop below? This question gives us kind of minimal information. We know we have Miss Amo here. Here's a backpack full of cement. She's dropping it. It's going to fall. And it's going to fall a distance. Right, we're going to call this initial point of xi being 0. We're going to call this final point down here, xf is 15. This distance, xf, is going to be 15 meters. Let's go ahead and grab our variables here from the sheet. We have xi, xf, vi, vf, a, and t. Initial position, final position, initial velocity, final velocity, acceleration, and time. Right? Where it is when it starts, where it is when it ends, how fast it's moving when it starts, how fast it's moving when it ends, the acceleration, how much its speed changes basically, and then the time that it takes to do that. So we want to know how long does it take. We're looking for a time, right? We have xi is 0, xf is 15. We actually can also know two more things here. We're not given an acceleration, but we can ask ourselves, okay, we're not given an acceleration, is the object falling? If the object is falling and nothing is in the way, then the acceleration is equal to 9.8. Right? So in this case, she's dropping a backpack off. There's no hill, there's no slope, there's nothing in the way. So acceleration is going to be 9.8 meters per second squared, pointed down, right? Because that's the acceleration of gravity. Now, our initial velocity is going to be 0, right? Because she's dropping this. She's dropping this from rest. She's dropping this with it, like she's not throwing it, she's not giving it a speed. It is leaving her hand with a velocity of 0. So our initial velocity is going to be 0. VF, we don't have. And that's alright, because we don't need it. All my homies hate VF. So we're going to use equation number 4 for this then. That's xf equals xi plus vi times t plus 1/2 a times t squared. Plug all of our stuff in here. We have 15 equals 0 plus vi is 0 times t plus 1/2 a is 9.8 times t squared. 0 times t is 0. 0 plus 0 is 0. This whole thing is going to be 0 plus 0 plus this. That drops out. So we have 15 equals half of 9.8. Half of 9.8 is 4.9 times t squared. Now, this t squared here, when you have an exponent that's attached to a variable, you want to get the variable by itself so you can take the square root of it. Right? So what we're going to do first is we're going to divide by 4.9 before we do anything else to try to get this t squared by itself. 15 divided by 4.9. We have 3.06 equals t squared. Take the square root of both sides of this. Oh, thank God, my phone calculator can do that. That's great. And we end up getting t equals 1.75-ish seconds. So this one's actually pretty easy. The only challenge here comes from being able to assume the initial velocity is 0 and the acceleration is 9.8. In this case, again, she lets it go. It says here specifically that she drops it. She lets it go with no speed, so its initial velocity when she lets go of it is going to be 0. And because it's in free fall, because there's nothing in the way, nothing is causing it to accelerate aside from gravity, the acceleration is going to be 9.8, which is the acceleration of gravity. And that information is on your reference sheet that I'll give you on the test too. So hopefully this is helping you guys out. I'll see you for the next one.